to continue in the review chapter, section 5, equations with real solutions. This is a chapter that has many types of equations in it. We're going to knock them out as we can, one at a time. We'll start with the most basic one, mention some of the properties of equality that we're going to use. But first we'll start off with some definitions here. Notice the first definition talks about a linear equation in one variable. A linear equation in one variable, that's the simplest type of equation. You get those way back in pre-algebra. It's a first degree equation. The variable's to the first power. Okay, then we have the definition of a solution to an equation. Now I know that sounds pretty self-explanatory, but a solution or a root of an equation is a value of the variable that makes the equation a true statement, that satisfies the equation. We want to make sure that we can take and check our answers by substituting them back into the original equation and seeing if we get a true statement. A solution set of an equation is the set of all solutions. I know you're not supposed to have the same words that you're defining in the definition, but that's a better explanation there. And equivalent equations are equations that have the same solution. So what we'll be doing in many of these cases, we'll be writing statements that are equivalent equations in which we can get to a point where we can solve it a little bit more readily. Now there are four main properties of equality that we use here. The addition property of equality that says if A equals B, then A plus C equals B plus C. We can add the same number to both sides. The second one here, if A equals B, then A minus C equals B minus C. Well, that's the subtraction property of equality. The addition subtraction property of equalities are sometimes grouped together since subtraction is the same as adding the opposite. Then we have the multiplication property of equality that says if A equals B, then A times C equals B times C. We don't normally let C be equal to 0, but we would get a true statement if it was. And then last but not least, the division property of equality that says if A equals B, then A divided by C equals B divided by C. C not equal to 0 here. We cannot divide by 0. But as you can see, in all four of these properties of equality, what you're doing to the left side of the equation, you do to the right side. If you add something to the left, you have to add the same amount to the right to keep it equivalent so that we have the same solution set. Now, I have the four steps here to solve a linear equation in one variable, and I'm going to point some of these out as I do the example there to the right. But simplify both sides of the equation. Of course, this is only when necessary. That means get rid of the parentheses by distributing, combine like terms if you have any. Sometimes this step is unnecessary. In the example that we're going to do, it is necessary. It just depends on the problem. Then we're going to get the variable on only one side of the equation. Now to do that, we'll have to use probably the addition or subtraction property of equality, but you can't solve or isolate the variable if it's on both sides. And then we're going to undo adding and subtracting. Now what I mean by undoing adding and subtracting is you're going to have addition or subtraction, perhaps, again, only if necessary, done to the term with the variable. We have to get the variable by itself. We want to isolate the variable, so we'll undo the stuff that's around it. And then we'll undo multiplication or division last, if necessary. So I'm going to point those steps out as I do this first example. So we're going to simplify both sides of the equation. We're going to get rid of parentheses. I have to distribute up here on both sides, as it turns out. This is the distributive property. I have 5x minus 20 minus 2. The 2 does not get distributed. Equals over here. Now I multiply through by 2. I get 2x plus 14 minus the 3. I have like terms on both sides. These are like terms. These are like terms. I'm going to combine those. And I have 5x minus 22 is equal to 2x. Looks like plus 11. Now, step 1 is done. I have simplified both sides. No more like terms, no more parentheses. Step 2, I need to get the variable on one side only. To get the variable on one side only, that means I'm going to have to get rid of the 5x that's on the left side or the 2x that's on the right side. I like to get rid of the smaller amount of the variable when I can. So in this case, I'm going to get rid of the positive 2x. And this is where one of these properties comes into play. I can subtract the same amount from both sides. So to get rid of a positive 2x, I am going to subtract 2x from both sides. Now I prefer, when you're writing this out, not to use the little shortcut notation, but to write it out as an equivalent statement so that it matches up with the property of equality. So I have like terms here, that's 3x minus 22, and I have like terms here, positive 2x minus 2x is 0 plus 11, it would be 11. So now I've done the second step. I've gotten the variable on one side. Now I'm going to undo adding or subtracting. Look over here, my variable is x, it's on the left side of my equation, it's being multiplied by 3, and there's a 22 that's being subtracted from it. We undo the adding or subtracting step first. In this case, we undo the minus 22. Now to undo subtracting 22, I'm going to add 22. Now a lot of times, teachers will show you to add 22, not to write it out in a statement like this, but they'll put like a little plus 22 underneath as a shortcut. I don't hate that, I just don't think it really represents the property. I've used it on occasion when I'm in a hurry, because this is just a little bit of extra writing. A minus 22 and a plus 22 adds up to 0, so that's just 3x, and over here on the right side I have like terms, I have 33. Now to undo the 3 that's times the variable, I do the inverse of multiplying by 3, just as I did the inverse of positive 2x by subtracting 2x, I do the inverse of multiplying by 3 by dividing by 3. So step 4, I'm going to isolate my variable by using the division property of equality and dividing both sides by 3. And I get x equals 11. Now that's my solution or my root of my equation. I can check my work by substituting 11 in for the variable in the original. Now I don't do this every single time because I've done enough of these that I feel pretty confident in my work, but there's been occasions where I wish I had, because I made a silly mistake somewhere along the line and I don't catch it by not checking my work. So on the left side here, I'll subtract. I have 5 times 7 minus 2. On the right side I'll add, I have 2 times 18 minus 3. So I'll multiply on the left side, that's 35 minus 2. I'll multiply on the right side, that's 36 minus 3. And I have 33 is equal to 33. That's a true statement, which means that 11 is a solution. Now, sometimes we just circle it, but if the book asks for the solution set, then we use braces, set notation, and we write it like this, as the solution set, it being the set just containing 11. The last equation that we did had a single solution, which leads me to remind you guys that when you're solving equations, especially linear equations that have one variable, there's 3 possibilities. We get a conditional statement or a conditional equation, an identity, or a contradiction. So I'm going to show you the difference between the 3, but essentially a conditional means there's only going to be one solution, an identity is going to have infinitely many solutions, and a contradiction isn't going to have any. So it says here to identify each equation as a conditional equation, a contradiction, or an identity, and then give the solution set. Well, I'm still going to use the same steps as I was using before. I'm going to combine like terms here. There are no parentheses to eliminate. And then I'm going to get the variable on one side, so I'm going to subtract 3x from both sides. And I get 1 is equal to 3x minus 2. Now, if you're not crazy about having the variable on the right side, you can change the order around. You can write the variable on the left side. Some people like it that way. It doesn't matter. It's equivalent because of what we call the symmetric property of equality, which says if A equals B, then B equals A. I'm going to add 2 to both sides. And I'm going to get 3x is equal to 3. Then I'm going to divide both sides by 3. And I'm going to get x is equal to 1. And since it asked for the solution set, I'm going to write the solution set right there as the set 1. When you get a single solution, when the variable stays in the equation all the way to the end, this is referred to as a conditional. I'll write it below here. This is a conditional equation. Which means that based under the condition, whether or not the solution is correct, that it can have a single solution. Now in the next example, I'm going to have to distribute. I have negative 10x minus 2 is equal to, now I don't have any parentheses on the right side, but I definitely have some like terms here, sorry, and that would be negative 10x, 2 minus 12 is negative 10, plus 6. Now I'm going to get the variable on one side. Usually I get rid of the smaller one, but I kind of notice here that it looks like they're the same amount of variable. So if I add 10x, it's not only going to disappear from the left side, it's going to disappear from the right side. Well, that's a tip-off right away that you have one of the two special cases. The conditional equation is the most common one. In this case, I have a false statement. I know that this is not true. This is a contradiction. This means there is no solution, and we'll use the empty set symbol for the solution set. So this is a contradiction. All right, my third example, gee, I wonder what this one's going to be. If I distribute on both sides, to simplify both sides, I have 6x minus 2 is equal to 6x plus 6 minus the 8. I'll combine my like terms. I have 6x minus 2 on the left side. I have 6x, a plus 6 and a minus 8 is a minus 2. And you're seeing this one coming, I'm sure. If I get rid of the 6x on the left by subtracting 6x, it's not only going to knock out the 6x on the left, it's going to knock out the 6x on the right, but this time, unlike the last example that gave me a false statement, this is giving me a true statement. This means that no matter what number I substitute in for my variable, I'm going to get a solution. I'm going to have a true statement. So this is called an identity, and we write the answer. Now, if I use set builder notation, which has the brace, it would be the set of all x such that x is an element of the real numbers. That would be my solution set in set builder notation. But we also know that in interval notation, that means from negative infinity to infinity. All right, that's the possibilities with the linear equations. I will make mention of a quadratic equation. This opens up a whole new world of fun for us. Quadratic equations in one variable fit this form: ax squared plus bx plus c equals 0, where a doesn't equal 0, but a, b, and c are real numbers. B could be 0, c could be 0, but a cannot if it's going to be quadratic. That x to the second power tells me it's quadratic. This is also referred to as standard form, where you have everything on one side set equal to 0, and it's in descending order. We typically get rid of fractions if we have them, and so on, but we'll get to examples like that. The idea of a quadratic equation, one of the first methods that you learn to solve a quadratic equation is to use the factoring that we talked about in an earlier section. Factoring is going to come into play, and so is this property called the zero product property. The zero product property essentially says that if you multiply two things together, a times b, and we get 0, then either a is 0 or b is 0, or possibly both. So we're going to use that property to solve quadratic equations. But first things first, I'm going to try to make it, excuse me, going to try to make, first needs of the videos, going to try to make this into standard form. So I'm going to distribute. I have 3x, oh, excuse me, got to multiply. I have 30x squared minus 10 times 13 is 130x is equal to negative 40. That's not quite standard form. I'm going to add 40 to both sides. So that I get 0 on one side, and I have it in standard form. And I have 30x squared minus 130x plus 40 equals 0. Now those are some pretty good sized numbers right in there, but they all end with a 0, which means they're all divisible by 10. So I'll just divide both sides by 10 to make life a little bit easier here. At least I hope it will. Both sides, every term on both sides, dividing by a positive 10. So that's going to give me 3x squared minus 13x plus 4 is equal to 0. Now here's where the factoring comes into play. I have a quadratic. I'm going to see if I can break this down. It would be kind of like the bottoms up method because of the 3 in front. But I'm going to kind of trial and error it here and hope that I can get this one to work. A 3x and an x for the 3x squared. I don't think it's 2 and 2. I think it's 4 and 1. And I think it's 4 here and 1 here, and they're both minus. All right, now it is factored. It is set equal to 0. I have a product of two factors that equals 0. That's the zero product property. That means either this first factor is 0 or this factor is 0 or perhaps both. So here's where I can take this complicated looking equation and break it into two simpler linear equations that I hopefully can solve in the space that I have remaining anyway. Hopefully I can solve. But I have two much simpler equations. I'm going to solve for x. I'm going to add 1. And I have 3x is equal to 1. I'm going to divide by 3. I'm really running out of space now. And it looks like I'm going to have to put it over here. X is equal to 1/3. Normally I would just put it right under there, but I'm out of space. Over here on the right, looks like I have to add 4 to both sides to get the variable by itself. To undo the -4, I'll add 4. And I have x is equal to 4. So I have 2 answers, which kind of makes sense if you think about it. This is quadratic, it's second degree, and you have 2 answers. Linears, for the most part, you'll have degree 1 and it's 1 solution. So it kind of matches up that way, but we'll get to that in just a little bit. Now I'm going to write the solution set. I'm almost out of space here, so I'll just put it over here on the side. And I have a 1/3 and I have a 4. I usually put them in order based on smallest to largest. And that's my solution set. Now that's a pretty straightforward problem. It may not look like it, and this certainly isn't the first quadratic equation you would get to solve in a college algebra class or a intermediate algebra class. But this one's pretty straightforward. It factored. It was a little tricky there. Dividing through by the 10 was the key to get this to look like something that I could factor to get the answer. But there are other methods, because as you will find out, not all quadratic equations will factor nicely. And there's different types of equations. Maybe you won't have an x term. Maybe you won't have a constant term. You're always going to have the x squared term, but it doesn't mean that all 3 terms are going to end up like in this example. But we'll get to those as we go.